Inventories have a buffering action, and the higher the inventory is between two processes, higher is this buffering action. But the buffering action presents us with two major concerns. Concern number one is buffering action tends to hide upstream problems or concerns or defects in the upstream processes. And concern number two is that the buffering action makes the process less agile or less flexible. Now, let's see both these problems with the same assembly lines that we had. Now, let's look at line 1 and suppose that I had 5 pieces of inventory that we talked about here. Okay, and given that each machine takes 5 minutes, the same as before, the gray machine is buffered by 25 minutes. So even if the green machine keeps failing for 5-10 minutes in between, or 15 minutes, or even 25 minutes, the assembly line does not stop. And so the breakdown of the green machine never becomes really visible to the top management of the firm. And so what is happening here, that the breakdown in the green machine is hidden because we have work in process between the green machine and the gray machine. And the higher the inventory is here, higher breakdowns in green machine could be buffered. So instead of 5, let's suppose I had 10 pieces of inventory, 4 and 5. That means now, even if the green machine fails for 50 minutes, the gray machine can still keep working and the defect would not become visible to the top management of the firm. But let's assume that there is only 2 pieces of inventory here. Well, in that case, this machine, the gray machine, has only 10 minutes of breakdown time available. And if it exceeds that 10 minutes of breakdown time, the assembly line will stop and the problem becomes visible to top management and everybody. So the higher the buffers, the less is the chance of the assembly lines coming to a halt, and the less is the chance of the problem becoming visible to everybody in that facility. That's the problem number 1. Now let's look at problem number 2. In assembly line 2, let's assume I have 5 pieces of inventory. 3, 4, 5. And here also I have 5 pieces of inventory. All right. Now let's say the marketing person here finds that we need to change something about the product because the market requirement has changed. Well, the change can only come after these 10 products, 5 products here and 5 products here have been processed. These 5 products would take 25 minutes to get processed, and these 5 products would again get 25 minutes to get processed. So a change can only be created after 50 minutes. But let's assume we did not have 5 processes inventories. We just had a lot fewer. We just had 2 pieces of inventory here and we had 2 pieces of inventory here. Well, in that case, the change could be created by processing after these 4 pieces have been processed in that 10 minutes, 10 minutes, and 10 minutes here. So a new change that the customers require can be made available in 20 minutes versus 50 minutes earlier. So when I have less inventories in my system, the system is inherently more flexible and able to satisfy changing consumer or customer requirements.